This livestream series is sponsored by Slice Engineering and the Mosquito Magnum Plus hot end. Push absurd amounts of filament while maintaining the structural integrity of the Mosquito design. The Mosquito Magnum Plus can be configured with up to 100 watts of heating power, redundant 500 degrees Celsius rated thermistors, and air or water cooling. I'll be using the Magnum Plus for this build, and you can find the links in the description below. Also, Do It 3D, the Voron printed forward team, and Lineo were kind enough to provide some of their high quality parts for this build free of charge. I've purchased the rest of the parts on the regular, like the FormBot kit, upgrades from Firmware labs, and little bits here and there. You can find links for everything in the description below. Now, let's get started with the build. Hi everyone! Hey! Welcome back everyone who's already joined in. Today we are, well, obviously we're continuing the build of the Voron 2.4, and we do have a video topic today that I think it's going to be hard to do on stream because it's going to be a lot of figuring stuff out, checking things, making sure everything works. And that is firmware configuration. That is, yeah, getting everything working as intended from scratch, pretty much. I've heard there's like a sample configuration for Do It 3, but I will be doing everything from scratch. It shouldn't be that hard. We have the config tool, obviously, that if we input everything correctly, it should output the correct config for us. Now, what I did since last time, since we had the Do It wired up and blinking and ready, is, so we saw the the red LED, actually this is now just being powered through USB. We had the blinking red LED. I don't know if the SD card was actually inserted, but I inserted that, I checked, and I could not get the web series. I could not get the web series. The web interface to load up fully, it was just like, well, here's your do it. Thanks, but I don't have a web interface to show you. What fixed that was basically just plopping on the full what's it called, do it web control files onto the SD card. I've read that those should be on there, but it might be that this is a kit that was, I don't know, on the shelves for a while, and it didn't have that fully newest set of configs. Hold on, I'm trying to reach out to sender. It didn't have both these sets of files for the Raspberry Pi that you can hook the Do It up to, because this has the full Raspberry Pi header that you can connect to and have that deliver your web interface and control this through serial, or having the Do It itself be the print host and deliver that web interface to your browser. And I'm going to be using it without the Raspberry Pi. I don't see the value in that unless you want to do like some super crazy stuff with it. For now, I'm going to rock it like this. But the FormBot kit did actually include a Raspberry Pi 4 2 gig. So that is both suitable for using it with the SKR or Spider or Octopus boards. I don't know if that yeah, well, obviously if it's Clipper, then it's going to need a Raspberry Pi. So that works with those. But of course, you can also plug it into a Do It 3. So yes, hello, my name is Chrono, asking how much does the kit cost. So the kit, the cost for this printer is a couple different components. If you self-source, from what I've read in chat, it's about, okay, this is not plugged in. It's about 1,500 money units, I guess US dollars or something. For me, I bought the kit for $899, I believe, dollars plus ship. It was like €1,000 for the FormBot kit plus all the components that I added on. So the kit would give you a full printer minus the printed parts, but it's yeah, I did swap out some components, such as I did use a Do It for a mainboard. I did get a new bed. I did so this the Do It was sent to me. The wiring loom from Linear was also sent to me. The bed I purchased myself. What else did I get? Yeah, and obviously this is using the Mosquito Magnum Plus, which is also not included in the FormBot kit. So overall, the printer we've got here on the table right now is about 1,600 euros to replicate as is. I think that's about right. So that's that. It's more expensive than a Prusa kit, but it should also be a teeny tiny bit more capable. Thank you everyone for the birthday wishes. Cursey Fabrications asked me, hey, if could I join the stream and like pester about the safety stuff on the Ortur laser that's gonna get unboxed there, but I don't think I'll be able to make that. I'm right now 3 hours of streaming, and then I'm done for the day after this. So parts I'm owning, including shipping, pretty much, yeah. So the add-on, the upgrade parts were purchased locally from Germany. Yeah, they were pretty much all shipped except for the wiring loom, which was shipped from Spain to me, directly from the folks who make it. Yes, that is pretty much including shipping. For the FormBot kit, it's $200 worth of shipping that you're paying, pretty much. $200 worth of shipping? No, $110 worth of shipping, and then $200 worth of imports and customs fees. So it does add up. It does definitely add up. So config. Like I said, what I had to do to get this showing up on the network, and I did do that off camera because I didn't want to start this out with futzing around and kind of figuring out why stuff isn't working and possibly running into walls. So that was just the files on the SD card. Added those, now it's fine. So we have an Ethernet cable that goes to the Keystone module that's back here. So in the mains inlet, there's a Keystone module, so you just use a regular Ethernet cable on this side, and then you plug in your Ethernet to your regular installation into the other side. I still have not hooked up the power switch on the IC inlet because the because that would expose more live wiring or live connections in the back, and I just, I have a switch on my power strip, so that's fine. Yeah, thanks everyone for the birthday wishes. My dad just came by and they brought some cupcakes and presents. Italian food. I always like that stuff. Righty-ho! So what we need to start with is not the config tool actually. So we do need to start with the G-code dictionary. That's something we're going to be referring to. Yeah, you always saw I looked up get endstop status because we will need that. But as far as I understand, since we do not have a config saved onto the board yet, so this is just blank. This has nothing on it except for the stock interface. We do need to give this a command to actually configure the Ethernet interface, and that is M552S1P0000. And that theoretically, so this is all the old stuff. I guess I could have cleared that. Can I clear that? No. Theoretically, that should configure Ethernet, and it should spit out an IP address in a second, unless it needs full power to boot up, which I will give it. Just gonna make sure I'm not reaching in here anytime soon. So let's see. Let's disable this again. Network stopped, and let's re-enable that, and it should spit out an IP address down here. So 000 is just saying, hey, get your IP address from DHCP. Oh, there it is. Okay, there, it got one of my least favorite IP address numbers assigned to it, but that should work if you just plop it into a browser. There it is. It's already got the title. And hopefully that should load up. There we go. Welcome to your new Duet 3. To go to this page for further instructions. Yeah, and that just gets you to the setup guide and the getting started. We've basically worked through much of this already with the wiring diagram and with hooking up motors and all that. Running in standalone mode, that is all going to get configured through the config tools. So yeah, this has the first setup basically is already done. We are past the magic smoke stage. Well, there was no magic smoke stage, which is always nice when you're using electronics that are worth more than a couple Chinese printers. Yeah. Next, yeah, I do have a couple devices on the network, but also my router kind of skips a bunch of numbers at the very start of the address range. So it's not that many. So it skips those that it can then use for manually assigned IPs. Righty then, ready-ho. So we got the rep firmware configuration tool. That's basically where most of the configuration is going to happen, except for the fact that we are using multiple Z motors. That's going to be a custom G-code line that I've checked with the Duet team just to make sure I'm not going to be running into any walls here. Yeah, but everything's happening in here. Jay is asking, what bed are you sing? I am sing the bed from Firmware Labs, the universal milled bed, because I was told the bed that is included in the kit might not be stress relieved and it might work. So please follow this wizard. Hi, wizard. You can rate your. So we don't have a preset. It would be nice to have a preset for a bunch more machines here, but. Custom config. So let's just work through this step by step. Repro firmware not clipper. Well, it doesn't run on the Duet 3, and I do want to use this as intended with the Duet 3 hardware. I do need a bit of expandability. Right. So Christoph Miller, we're gonna please remind me in a bit to do the config stuff for that if we need to do that still. CJ, that is wrong. Parents are both German. So, Duet 3 mainboard 6HC. So, first and foremost, the mainboard is our main and only point of contact, and then from that out, all the other stuff branches out. So 6HC, we do want to run it in standalone mode without the single board computer, which is the Raspberry Pi. So that's the Voron. That's how it's going to show up in in DNS as well. That's going to be the name for this here, myDoit, and myDoit. That's going to say Voron, and we're going to be able to type in HTTP Voron, and that should give us the web interface once the config is uploaded. So, save state, don't want to do that right now. Read config override, yes, we will need that because we will have some custom setups. We have a Core XY with, let's just start with 290, and we can always expand our maximums a bit should we need to. Probably the Y should be a bit larger if you want to reach the tool length sensor, if I ever end up putting that on, though I guess I should. 290, Z maximum, let's stick with 250 for this, because if you go too far up with this, well, it's going to be smashing the Y-axis, the Y drag chain, but it shouldn't, like, I'm just worried that it might pop the carriages off the rails, and I don't want to risk that. 250, like I said, this is safe limits for now, and we can increase these at any time later. This machine uses coupled motors to position the nozzle on the, so that's just a description for the Core XY. Okay. Homing preferences, 36, yeah, that sounds about right. Yeah, that looks good. Yeah, Chrono, just saw the speed on this printer. Yeah, so the speed is something that I'm hoping we're going to achieve as well, because we have some pretty crazy drivers on here. We have the 2160, I believe these are called, with discrete MOSFETs, and we have the 5160s on the expansion board. So that is going to, I mean, the limit is going to be our stepper motors kind of running out of current we can push through them. So we are actually homing to max, Christopher is saying. Let me just verify that. So you move to the right and you move to the rear. Okay, so we are homing to the maximum positions, not the minimum as you typically would. So let's, that's going to get configured later. Okay, just making sure we're not missing anything. So first of all, we need a expansion board 3HC, because we do have that configured, and that should, simply because it's plugged into the CAN connection, so that's this white RJ11 cable here, goes into the CAN output of the 6HC, goes into CAN input on the 3HC. It's got both termination jumpers in, so theoretically that should get detected straight away. So obviously the config tool does not know about the printer yet, because this is just running in the browser and it's not communicating with the printer. Yeah, it's not communicating with the printer hardware that is plugged in right now. So can we actually just configure this with, no. So this is something that the config tool does not allow us to do yet, which is configuring multiple drivers for the same axis. So we can just select one, and we're going to have to override that later in the custom G code. So let me get out my handy dandy wiring sheet. So X and Y, obviously this is using a different lingo than what the Voron is using. So for the Voron, because it's Core XY, this is not X and Y, this is A and B. So I am thinking X is just going to be the A axis and Y is going to be the B axis. So we have plugged in the A axis into driver 4 and Y into 5, and we might need to reverse these, but that's going to be something when we get the thing running. So endstop pin, same again. So endstop pin was, where's our endstop? Okay, so these we will need to figure out as well, because it's just two nondescript wires that I'm routing in here. We've got blue and red, and I don't know which way these are plugged in. So end stops we will need to test once this is uploaded. So end stops are IO 1 and 2 on the 6HC. So you can see we have the board 1, which is the expansion board. So the 3HC, and then these are all the ones on the 6HC on the main board. So for the end stops for X and Y, we actually have I've wired them up. I've wired up the end stops not to the recommendation of the Voron build manual because I was stupid while installing those. So my end stops are basically open when they're not triggered, and they're closed when they are triggered. So that makes it a bit hard to diagnose wiring failures or end stop failures, but it's what we've got to work with for now, and hopefully it shouldn't be a problem. So what we need is what we need is the pull-up active, and they are active high. So that means we're connected to IO1. We are active high, and we need a pull-up. So that means the board itself on the outputs here is outputting a small voltage. Well, 3.3 volts typically it's going to be pulled up to. It's outputting that, and then the end stop shorts that to ground. That's the way this is wired up. That shorts it to ground, and then on the input pin, where the board also outputs that voltage, you're going to see the voltage drop, and that's what's going to get registered as a end stop trigger event. So that is on IO1 in pull up, and the second one is on IO2 in with a pull up as well. Z, we don't have a Z end stop per se wired up. That would be the tool length sensor basically. But I don't have that installed or wired up for now. I think it would be smarter to actually use the tool length sensor as an end stop instead of using the probe as an end stop, simply because that's going to be more reliable. But like I said, not wired up so far. So we do need the probe configured in a second. All right, fans. So we can just add more fans as long as we still have more outputs, and I think that is pretty cool about the way that Firmware is now being configured. There's no fixed input outputs for anything. Any input output can be anything. So we have a heater fan was connected to out 7, and the part cooling fan is connected to out 8. So right now we're just assigning those to fan 0 and fan 1. And in one of the next steps, well, 4 steps down, we're going to assign fan 0 as a hot end fan with a thermostatic control, and fan 1 as the part cooling fan that's going to be configured just with G-code. Next up, heaters. So we have, that's also going to be assigned to the thermistor inputs here. Wait a second, that's not Clipper. No, this is not Clipper, this is Firmware. Heaters. Bed is assigned to, what are you, out 0. So that is out 0. And thermistor 1, temp 1, and that's what I noted that down with. Of course, I guess it should have been temp 0 to match up with the output 0, but it is how it is. And then hot end is plugged into, where is it? Hot end. So for now we're just going to use one heater to output 1. We're just going to use one heater, and then later on I can configure like both heaters to be active at the same time. For now, the heating power is going to be enough, but eventually I do want to make use of all the features on this machine. But like I've said before, right now the goal is to get this thing working and functional, and then we can start tweaking and getting it perfect. Right now, I just want to get it. I just want to get it moving and printing for the first time. So output for the nozzle is out 1, and temperature sensor is temp 0. So that's connected. All right, Z probe. Input pin. So modulation pin and PWM control channel. The modulation pin I don't think we need. We just need the input pin because everything else is, wired up elsewhere. And the probe, I don't know if I noted this. Yes, I did note this down. The probe is connected to IO3, and we might need to change this to inverted if we figure out that, hey, the probe is giving us a triggered signal when it's actually not being triggered. So that should be everything on this page. We have the expansion board. We have all the drivers for X, Y, Z. Z we're going to have to overwrite. Actually, let's assign you to driver 0, but that's going to get overwritten anyways. Temperature sensors are correct. Outputs are correct. All that. Paul, yes, the pins on the DIY. I'm reading Nero's chat here. The pins on the DoIT are all 30 volt input compatible or compatible tolerance. So they do have a bunch of I don't know what this is. Looks like a transistor, a couple resistors, capacitors. So there is a bunch of small electronics on each of the input pins, and you can connect the probe output to an input directly on either one of these inputs. So that is just the signal wire from the probe going directly into the I/O pin. But each of these inputs is 30 volts compatible, as well as all the expansion inputs on the 3HC expansion. So those are explicitly compatible or tolerant of 30 volt inputs. Right, extruder E0 drive is wrong. Hold on, did we miss that? E0 driver 3, okay, thank you, but... Nope, okay, thanks for catching that, Gianni Grunau. So our extruder is hooked up to board 1 driver 0. Cool, that's that. So, board 1 driver 0, so that's just how the expansion board shows up. It's just another option in your input selects. Why is that mouse over not working? Oh, because these are grayed out because they're being used. Would be nice to have this a bit larger so we actually see what's selected, but anyways, that should be configured. Axes. Decisions. So X forward, Y forward. That's going to be something we're going to have to test once it's running and moving. X forward, Y forward. Let's just assume this is forward for now. Steps per millimeter 80 should be correct. It does have a calculator built into the config tool. Actually, you know what? Should we do 16x or should we just bump it up to like 64? Let's just do native 64. 128? Nah, let's stick with 64. Can't use part-time roaming? Yeah, I mean, you can use the plus button to add more axes, but you can't add a second Z axis. That's not something you can configure in the config tool, unfortunately. 80 steps per millimeter should be correct. So that's 80 mechanical steps. Well, anyway, I trust the 80 at 16x. Okay, so we're setting this to 320 because we're doing 64 times microstepping, and we've got a 20-tooth pulley if I'm correct. Yeah, DUI 3 can interpolate from any stepping. Why not native 256? I don't want to run out of step pulses. So I don't know about that. JShay, Voron does include firmware. There are config files for the firmwares available, but just not for DUIT 3 yet linked anywhere. So I've heard there are some available from some folks on Discord, but I want to do it manually for now because we are deviating slightly from the official build. Okay, so 64 times interpolation, and I believe it's a 20-tooth pulley. It's a GT2 belt, so that should be correct. Maximum speed, 100 millimeter. Come on, who are we kidding? Acceleration, like that much acceleration to start with. And motor current, let's just start at 1500 milliamps. Nope, not 15 amps, 1500 milliamps. That should be reasonable starting points, right? 64 without interpolation will be noisy compared to with. I mean, I guess I can bump it down to... Oh, we have the... Hold on, we have the on setting with interpolation on. Okay, we can do that. We can do that, and that is still going to be the correct one. Okay. Z, forward. Yeah, current we're going to set here, I believe. Let me just check what the G code is. Yeah. Current we set here, so current for the Z-axis. Don't think we need to do that much, but let's just go 1200. Acceleration, 4K and maximum speed, 300. Okay, so steps per millimeter. We are geared down 4 to 1. No, we are geared down 1 to 4. And we have a there goes the gearing. We've got standard 1.8 degree motors. We have a belt. We have GT2 belts, a 2mm pitch, but we are geared down from the 20-tooth pulley by a factor of, I believe it's an 80-tooth pulley. 16 to 18. Right. 16 to 18. So let me just get out my math app. So we have... So standard steps per millimeter for the pulley for the 80 is for the 22th. Hold on, for a 16-tooth pulley. No, wait. So what's the pulley on the motor and what's the pulley on the belt? Because those are different, I believe. Yeah, so the belt one is a 20-tooth. And the motor pulley is 16. So what we're actually seeing is a 20-tooth pulley driving the Z-axis, but then we have 80 geared down 16 to 80. 1 to 5? 16 might be 1 to 5, yeah. Anyways, let's do the math. So 80 divided by 16 multiplied with 80. 400. Yeah, that's 1 to 5. Okay. Simple enough. So 400 steps per millimeter for the Z-axis with the gearing. Okay, then extruder. 64 on as well. What's the steps? 420 sounds about right. If somebody knows the exact steps per millimeter for... No, we do have a different mic. Oh, hold on. Hold on. We have all the stuff here. So we have roughly a 7mm hop diameter. 1, 2, 3 sounds about right. And then we can do extrusion calibration right in the firmware config tool. That is pretty cool. That is pretty cool. So that looks reasonable. And then, of course, we're going to have to calibrate that in due time. Max speed change. Yeah, so current is going to come way down. 350. So supposedly the motor is rated for 1 amp, but really I don't want to push that little pancake motor with 1 amp. Maybe let's do let's stick with 350, and that is RMS current versus peak current is what the motors are rated at. So just stay slightly, well, not exactly though, but stay slightly below what the 500 is fine. Let's do 400. So I guess the common practice is to stay slightly below the rated current for the motors. Say like 80% or something, and that should be good for now. Reduce motor current when idle. Yeah, 30%. And the Z-axis, because we have the gearing, the Z-axis is not going to drop without any current. So I guess we could reduce this even more idle timeout. Let's get this down to like 10 seconds. Just keeps the motors a bit cooler. I guess the z-axis should actually benefit from that if it's not moving between layers, or if it's only moving between layers. End stops. We could do sensorless. Wow, we can actually do sensorless for Core XY. Cool. But we can just do switch, which is what it is, and we have the end stops at the high end. Z, none configured because we didn't assign any pins here. I guess Z end stop we could use the Z probe, but the Z probe config down here is right there. So why are you okay? We have a switch, and now we can use the Z probe as an end stop. Okay, makes sense. I guess offsets because we're not doing RoboChurch. I hope the z-axis will not drop without current. At least it's not been dropping for me. That would be bad between prints. So you would need to keep your printer powered up the entire time, or you're gonna have to recalibrate the entire z-axis. This printer does not drop without current, so I can fold this, or I can put this back up on its feet, and the z-axis is not gonna drop down. So I don't see what the problem would be there. We'll drop the microstep, Christoph, but it will jump back to it. It will jump back into its microstep though, if you reapply the current, and dropping it down by 30% current. That shouldn't. I mean, yeah, that shouldn't be a problem. Okay, z-axis. Low end Z probe there. Okay. We're just gonna need to make sure to probe in the center of the bed. So I guess no G28 without doing. Oh, Y25 should be the offset. Okay. Let's see properly then. So we're gonna have to do G28 XY first, and then move it to the center and home there. And there are macros for that in RepRap. You can set that all up nicely, but that is again more advanced stuff that I can do later on. Trigger height 2.5. I don't know about that yet, but it looks about right. And we can fine adjust that if we had an analog probe, we could actually do that here and adjust the trigger position, the trigger. The exact trigger value. If you want to configure BO touch. Okay, we're not doing that. That should give us readouts for the z-axis probe in M119, which is readback. Where are we? M119 get end stop status. So that should report back the example output. Maybe? No. But that should give us the output for the probe that we need to see if this is inverted or not. Next, heated bed. We could do PID with the SSR, but I'm gonna stick with Bang Bang for now, especially because we have so much thermal mass with the thick. You can see that how thick the aluminum bed is there. I think Bang Bang should be fine for now. I have used PID with an SSR in the past, but not sure about using that with the cheap gold SSR. Heater configuration, heated bed. Actually, where do we click? There. We get a example config for the, I guess this one. Just a standard 3950K. Beta 4 and 1000 ohm, 10,000 ohm thermistor. That should work. And then the nozzle, we actually have the preset for the Slice Engineering high temperature thermistor. 500K, 4,723, and then a C value of, I don't know what this is, but that looks about right. And that is actually, I checked. before I started the stream, I checked which thermostat I should be using, and that is the exact one that's in here.
Thanks for inspiring and entertaining us during the pandemic. Again, you make me want to build yet another 3D printer. But how do I tell my...
Thank you, Marcos, for the generous tip. Yeah, well, like I always say, these streams are not just entertainment for you; they're also entertainment and some interaction for me during this crazy time. How do you tell the wife? Well, does the wife need to approve of everything? Not necessarily, right? Anyways, thank you very much. Cooling fans. Where are my fans? Oh, my fans are right there in chat. Haha. What a joke. Heater fan. So fan 0 was the heater fan, or the hot end fan to be exact. So now we need fan 0. That's the hot end fan that needs the thermostatic control. And we're monitoring E0, and it's going to turn on above 45 degrees on the hot end. I don't think we need to go that low, but hey, better be safe than sorry. Frequency 500 hertz, so that might ring at a kilohertz. If it's noticeable, if it's audible, then okay. Fan 1 is the part cooling fan. You're going to go to 0. And I guess you're being monitored anyways. That's okay. We're not monitoring. That should be all right. David Randolph, you will have to clean up the wiring. Sure, I will need to clean up the wiring. But I think like 2 streams back or something, somebody from the Voron team was like, well, just put the bottom plate on and it's going to be fine. And that sounds about right. I mean, I do have the zip tie sticky pads that I can use here, and I will use that. I will clean this up. This is not something that I do want to have, in a printer like this. That's messy wiring, and we do have a way of doing this a bit more cleanly, maybe separating the 230 volt stuff, which is pretty open here, from the rest of the low voltage wiring, maybe putting like a little spacer in between here, or just a plastic piece. We can clean this up. This isn't too bad. There's like only a couple points where stuff is going to and coming from, so it's fine. It's fine. Okay, tool change. Select the first tool and startup. I guess, yeah. Tool number 0. We only have one tool. That is the Magnum Plus. Is our default tool. Actually, can we zoom in here? We're gonna have to scroll a bit more, but yeah. Magnum Plus is our default tool 0. That is extruder 1, heater 1, extruder 0, heater. Why are you? Oh, because heater 1 is the. Though fan 1, should we assign that or not? Oh, we can't unassign it. Okay. So fan 1 is the part cooling fan that is attached to this one hot end. Offsets 0, fine. Mesh probing. Should we try and do mesh probing? I guess while we're at it, just one step here. But let me give this a safe margin. So you're gonna go from 40 to 260, and then here as well 40 to 260, and grid spacing. I guess 20 is fine. This thing is fast. Orthogonal axis compensation, maybe in the future. We are not using a 12:860 or a 128/64 display. Could we use that on Duet 3 at all? I don't know if there's like some extra hardware that you need to configure, because right now I can't actually enable this. Nero, yeah, you're right. Mesh leveling shouldn't be needed, but hey, why not configure it? Should I ever run a G29 by accident? I don't want to run this off of the side of the bed. May as well have it. I'm hoping this bed should be flat, because the gantry should be flat, and the milled bed should be flat, so we shouldn't need it. Okay. We are enabling network, yeah, so that's going to take care of the G-codes that I sent earlier. So we're not going to have to send that manually every time we boot up the printer. That's going to be done automatically. I could set a manual IP, but since we have it accessible through HTTP Voron in the future, hopefully, that should be fine. Get the latest stable repro firmware version, I guess. Okay, so full list of available G-codes, yeah. Custom settings for config.g. So what we need to do is... Christoph, thanks for that. Mini is only supported by the Do It 3 Mini 5 Plus. The Mini 12864. Restart now for important updates. Windows, what the... I'm in the middle of a stream, can't you see? Hoping that didn't like trigger some sort of timer. If I'm gone in a minute, my Windows is gonna have restarted itself. Like, yeah, I do have a panel duo that I've never used, which is I believe like a 7-inch touchscreen or something that you can just plug into the Duet, and it just plugs into one of the IOs. It plugs into IO 0, I believe. This one, if I'm not mistaken. Yep. Just plugs into here, just uses a single IO pin and gives you a full touchscreen interface. So, yeah, Panel Duo is going to be something that I do intend to set up for this. And I think it should fit nicely. Like, this is the front of the printer. Just have it at the front here, angled up. It should be pretty neat. And that is what's... that is specifically made for the Do It, and should give me an interface that is going to be rough, well, very capable at least, and should give you most of the functions that we can get through the web interface. And if not, I can always, hot glue one of these like cheapo convertibles to the front of the printer, like that. You know, that should be good too, right? Netbooks, there was a craze about these for a while. Now they're like, nobody's caring about them anymore because they're too slow for most stuff. Enable support for Panel Duo, not yet. So, what's getting disabled here? Weather forecast in the taskbar. Yeah, that's obnoxious. It takes you to MSN, of all things, MSN. So, for our z-axis, let me just make sure we're getting this right. So we have z 0123 connected to drivers 0123 on the Do It 36HC. So that would be M584. So M584. M584, and this config is going to have a bunch of M584 lines in there already to map the drivers to the X or A and B axes, and the the extruder axes, and the one driver that is currently assigned to Z. So M584 thankfully also allows us to do multiple axes. Does not remove its old assignment. I guess if we double assign it to the same axis, it might be... okay. We're just going to have to try that out if we... we're just going to have to see if that actually works like that when we double assign it, if one of the motors is going to move at double speed. But that should be pretty obvious, right? So M584, and then you can do multiple E motors in this case. So like 4, 5, 6, all E motors in this case, or 2, 3, that is 2 Z motors. When we're doing do it 3 with the possible expansion boards, yeah, a bunch of stuff here, that is the lingo we're going to have to use. So 3, 4, 1.1. Okay, 0 is implicit, so that is basically what we need. 0.3, 0.4, and then you can mix and match with the other drivers. So for us, because we're using board 0, let's do this explicitly. We're configuring the Z-axis 2. Board 0, driver 0. And then board 0, driver 1. Board 0, driver 2. And then board 0, driver 3. So that is the first 4 drivers on the main board, on the main 3HC as we have 6HC as we've plugged it in, are now configured to be Z-axis drivers. And there is a feature that you can auto-level that by having each motor connected, but I believe that should work for that because there's no other way to assign these to like multiple Z-axes. And Christoph Müller, I believe, was also saying something about having to configure something else, but I think that should... Oh, I'm using the wrong mouse, of course. I can't scroll up in chat. That should be... Edit M584 in the config editor itself. The thing is, if I do pull a fresh config through the config editor, then that's going to get overwritten. So I'm going to try this. I'm just going to try and see what happens with this. So, okay, configuration ready. We've moved through all the steps. Next step is M671. What is M671? 671. Okay, so that is to do... Right, that is to do individual Z motor bed leveling, which we don't need for fudge factor. Interesting. We don't need that for now. So that is basically what we're going to get. Download configuration bundle. And that is our config zip. That's sitting in downloads. All we need to do to apply that to the do it is go over here to system, upload system files, and we can feed it that config.zip. Actually, first config zip and downloading on this computer. We just need to feed it that config zip, open, and that is uploading all the bits, applying them, and actually updating the firmware at the same time. Cool. Okay. And I believe we need to do a little restart for this. Do we? I believe so. I'm just going to hit reset. And that should reboot everything. And oh yeah, there we go. I can hear the fan going. Ah! I'm going to pull out that USB. I'm going to pull that off the board. Okay, I think actually we are done with USB being connected to the board, so we can unplug this. Oh, I might actually have kind of damaged that port now. So let's get this back up on its feet. Just wondering, yeah, that the frame shouldn't be buzzing because it should be grounded. I'm sitting on the Ethernet cable, on the internal one. Okay, so we have the firmware open here. Let me jump over to console. So M115 is verified firmware version. Yeah, and it is, first thing we can see, it is correctly identifying as Voron, so it did eat that that update. firm version 3.2.2. I don't know if that is the newest one, but I believe so. I think 3.3 is in release candidate state right now. The hot end cooling fan currently is spinning, which I don't like. And the Magnum Plus is reporting 59.5 degrees. I also do not like that. So that, obviously, I mean, I can touch this. This is cool. This is not heated up. So that kind of tells me that I'm using the wrong thermistor.
May the gods of DIN rails and firmwares protect you today. RRF config is never trivial.
Thanks for the 10, Derek. May the gods of DIN rails and firmwares protect you. Wrapper firmware is never trivial. Well, the thing about configuring firmwares is, you know, whichever one you configure, you're going to be comfortable doing that, and you're going to know those details. I've configured wrapper firmware maybe twice or 3 times, so I'm not exactly firm in all the details that go in here. And if I look at the where is our config.g, if I look at all these config options, yes, it has the commentary there, but I'm like, well, I wouldn't be able to set this up by myself manually without an assistant.
It's a huge help when ordering parts for my build to see the order of operations and know what order to get things.
Thank you for the 5, Joseph. Glad I can be of help here, even though, like I said, I'm sometimes struggling here myself. Maybe that's of use too. Maybe that is of use to people who are trying to build one of these, and maybe it gives you a realistic set of expectations for building a printer, right? I've built printers before, I think, and yeah, not everything is totally trivial, but that is very rigid. But yeah. 2 opposing corner motors should be running in opposite directions. How do I do that? Anyway, yeah, so that is the config we have in here. And I think we can edit this right in here, should we want to. So there is our Z mapping config. Actually, let's remove this, because why not? So I believe not yet. So we have config. Where's our config override? Maybe a config tool. Where's our config override? Am I missing something? Did that not? Oh, custom settings for config.g. Okay. Just looking in the wrong spot. So if you go in here, that should go there. We might be able to just invert these like that, right? Do it wiki motor direction setting. Okay. So has been created yet. Yeah, I was thinking my custom setting here was going into config override, but it's actually going into config, so that's fine. Invert motors at the top. Physical drive goes forward. Okay. So basically, well, I guess that the config tool goes out the window right now. Basically, what we're doing is adding a couple more of these for the z-axis. Then S1, S0. Let me see. Set motor S direction of movement. So 0 is backwards, 1 is forwards. Okay. So theoretically, all we need to do. It's always the last tab you click. So physical drive 1, 2, and 3. That's our 3 z-axis drives. Basically, we invert. Yeah, because these are built mirrored. If you look down here, basically this side, if the motor is wired up the same way, and they are, if this one spins clockwise, the z-axis moves up. And if this one moves clockwise, the z-axis moves down, yeah. So this should be my inversion. Okay. Thank you for the who pointed it out? Somebody who pointed out that that spot there. Okay. 1, 2. These arrow keys are garbage. 3. Add the build plate before homing. Okay, good point. So there is I was told there is a RepRap firmware core XY direction test available somewhere. The thing with RepRap firmware is everything is documented. Like there is an absolute abundance of documentation available for RepRap firmware, and it's at the point where it's almost too much, where it's like you have to search for the actual wiki page you're looking for, because there's so many others, and it's pretty easy to go in circles on all the documentation files there. But pretty much everything you're looking for is already documented. Nira, thanks for those links, but those are on my streaming computer. I'm not going to be able to get those onto this one. I'm just going to try the Core XY guide for RepRap firmware specifically. So movement section, that should all be done by the config tool. Testing motor direction, right? Motor connected to the X motor moves the head in the X plus. Oh, I don't know. G1 H2 X what? What is H2? If the head moves that, so you can directly move the motor. Okay. The head moves diagonally in the plus, all is well. If it moves in the minus X and minus Y, change the. Actually, let's do it. Let's just do let's save this. That should be the Z-axis saved. Let's just do a quick manual move. Let's just do a quick manual move and see where that takes us. To reconnect, come on. Come on. Let's try HTTP Voron. There we go. So apparently got a new IP address. H2 believes homing, okay. So let's try this. Theoretically, I should be able to gently push this around. Let's just try X plus 10. Nothing happens because it's not homed. Ha! Well, H2 is an individual. What if I tell it, what is it, G92, right? G92 X 150, Y 150. So that should put the, oh, you didn't see that. Sorry. G92 X150 Y150 basically tells the board that, hey, it's you are at position 150 as is reflected in the tool position here. So now we should be able to do a X move. It's the wrong direction, but it is moving, and it is moving very smoothly, which I do like. Now, getting around the logic of which axes I'm going to have to invert. So Y plus 10 moves Y minus 10. So that should be easy. Just invert X and Y, and that should be it. I believe. Oh, I'm pushing on the Z-axis. Whoops. Oh, first move, by the way. Yay! Hey, nothing's catching on fire. that is such a massive stone off of my shoulders. Whew! That fan is annoying. Well, the thermistor is off. The thermistor is wrong. The thermistor is currently still reporting 60 degrees, so I will need to redo that thermistor setup. Okay, so system. Basically just invert X and Y, right? So that should just be these. Just double check 4 and 5. Yep. So if I invert this one and invert this one, all should be well. Philip, no, the stream is not. Why would the stream be over? Unless Windows decides to pull an update on me. Nothing should be over for now. I will try to get as far as possible today. Maybe set up a slicer, maybe get a first bit of filament out of this extruder. Maybe. Someone was commenting I should put the bed on before we do any Z homes. That is probably a good call.
To celebrate the first move, smiley face.
Thank you for the vibe. Definitely a reason to celebrate, Soren.
Thank you for the work on creating these live streams.
And thank you for the 10 BLY. Glad you're enjoying them. I mean, yeah, live streams are special, right? It's not something that everyone likes, but hey, if you like it, good on you. Okay, disable hot end cooling fan on startup. The thing is, next. The thing is, the hot end cooling fan is not manually controlled. It's controlled by the temperature that the hot end is reporting, or that it's reading from the thermistor at that time. And when the thermistor reads over 45 degrees, it turns on that fan. So currently the thermistor is reading 60 degrees, which is wrong, which I believe is just because I did configure the wrong thermistor. I configured it for the high temperature thermistor, for the slice engineering high temperature thermistor, but this must be the regular 350 degree one. So yeah. So console, can I just... Why did you go? Where did the G92 go? X150, Y150. So now you are homed. And then we can check again if they're moving in the correct direction. Let's get you to roughly 150, 150. X plus 50. No, that was Y plus 50. X plus 50, yeah. Y, X minus 50, yes. Y minus 50. And just a quick double check whether this is actually 50 or whether I've got these steps wrong. Because you might have a 16-tooth pulley, but only a... We might have configured the wrong pulley size. So let me just get this on here roughly. Let's do it like that. So I'm just going to line it up with the rear edge of the X end here and move forward by 50. That was X. That is pretty much exactly 50. So, cool. Works. That works, and that is the correct steps per millimeter. It's the correct directions. Actually, so that's X plus, and that's Y. Now, so confusing looking at this from the side. So that is X plus and that is Y plus. So X plus, Y plus. Nice. All right. So, yeah, so home 0, 0 should be in this front corner. So X, Y, and then Z up. That is always relative of the nozzle to the bed. So this is 0, 0, as it is actually in every... Y is inverted? Oh, you're right, Roland. The thing is also when you look at Y plus minus, it's backwards on a Betzlinger printer because the printer a Betzlinger printer would move Y plus, it will move the bed forward, and here it's the toolhead itself. So thank you for the 5, Christoph. Yes, we have figured that out. Back corner being 0, 0 is always wrong. A machine that's like universal CNC convention. Front left is 0, and then it's X, Y, Z. Your thumb goes to the right when you're looking at the machine from the front. Whichever CNC machine you walk up to, X goes to the right, Y plus goes to the back, and Z goes up. And if that's not that way, then it's wrong. And this is also wrong. So let me see. How do we invert this? Because if we...
Shouldn't Y go to the back?
Yes. Connecting a... Nope. There. We actually need to swap the X and Y motor drivers. That's what I believe we're going to need to do. So let's just do it by the manual for now. So G1, G91. I guess G91 just disables homing. Console. And then doing... Let's just see if this guide actually gets us where we need to go. Okay, where did you move? That was too quick. So this is moving diagonally front right. If it moves in the minus X and minus Y, no. If it moves towards plus X and minus Y, yes. Then either turn the power off and swap the X and Y motor connections, or use M584 to swap X and Y. Did I really plug in? No, okay, because X... That makes sense, yeah. Repair Firmware doesn't call it A and B drivers. Repair Firmware calls it X and Y, and like I guess the way that Voron mechanically thinks about A and B is not X and Y, but Y and X. So, okay, not unexpected, not unexpected at all. So in config, we just need to invert these two. No, we need to invert the assignment. There we go. So Y is driver number 4 and X is driver number 5. And reboot. G91 is relative coordinates. Okay, makes sense. So if we... So that's rebooting. Yeah, that is the web interface on RepRap Firmware is real nice. It height map, if you use Z probing, that gives you a 3D height map actually. Dashboard got all its stuff there. Jobs, full job. I mean, it's a really nice interface. And the thing is, I almost feel bad for Octoprint because if you're using a Do It and you have an interface like that available to you, for me, this was good enough to not bother setting up Octoprint. Sure, you're not getting camera feed, and that is, I think, the biggest feature actually of Octoprint. But this is like you've got everything you need basically to run a printer just straight from the board with no Raspberry Pi or anything connected. UI config editing and camera not okay. So here I was reading that as there is a config option to add camera support. Like what? Yeah. There is camera support in RepRap Firmware, but not with. Oh, Volker, okay, that makes sense. You can add a webcam URL. So if you're using something like a security camera, which I have, like the TP-Link cameras, you can add those, and then it's going to display it in the interface, but you can't directly plug in a USB camera to the Do It. That would be odd, but yeah. Right, so that should be all set up, and we might need to invert the motor directions again. Not sure about that, but if we move in X plus, and if you move in Y plus, so now X and Y is correct. Should we try Z? Haunted fan, oh, the noise. Okay, so let's just get rid of the noise and configure the thermistor correctly. So config G, where's our thermistor? There's our thermistor. So Slice actually has a engineering thermistor do it. It actually has a wiki article about the setup process with do it specifically. So that, okay. In the M305, M308, so that's the values we have for the high temperature thermistor. What are you? You are the... I guess we have the 300 degree thermistor. RT table, nope. Where is that setup I was looking for? Come on. That's that, and I don't think it's these values. That's just the defaults. There we go. If you're using the 300 degree thermistor with do it rep, okay. So it's 100K. I would assume then R2. Use the following. Use this. Okay. Use this. Enter this. And you good? I would assume that's the correct one then. So up here we're at 60 degrees. Restart, and that should... Ah, fan's off. Okay, so that's better. 19.6. Yeah, that's more like it. Can we zoom in here? Do we need to zoom in here? Nah, it's already so tight. So that is better. So this is a 300 degree Celsius thermistor. Cool. Change fan, PWM, help with fan noise. I would think that this is running at full speed. So yeah. Heater 1 active. Well, it's active, but it's not set to a temperature. So I guess we could... No, we can't actually cycle you off. Oh yeah, standby. We can't cycle you to standby. Why are you active? I don't know. I think it's just set to 0 degrees, so yeah. Cool. Now it feels weird. Turn on fan again. Probably didn't sound too nice with the noise suppression and everything going on. It was probably weird to listen to. Sorry. PWM frequency, it's at 500 Hertz right now. So heaters are correct. XY movement is correct. Now Z-axis. Do we just move the Z-axis and go like, hey, let's see what happens. So we're telling it Z is at 150, roughly. That should be roughly correct. I mean, we did do the config where we set each, don't do a lot move. Yeah, I'm not going to do 100 mil first. Can we do each motor individually? I think we can with the H2 or something. add the nozzle switch. Christoph, yes, I will. I might add that in the future. Actually, does that reach? No. Where does that go? I guess I would need to move the bed out of the way for the hot end to actually reach the switch, but not adding that right now. Right now, I've got the probe on there, so yeah. Let's try the z-axis. So before we try any homing, let's just try the z-axis and see what we get. So if we move z, let's do 0.5 first. So theoretically, everything should move up or down. If one of these motors actually moves in the opposite direction, there's something seriously wrong. So if we hit plus 0.5, 3, 2, 1, down. Yeah. That's a nice and fast z-axis. Sounds pretty good too. Like, man, that's a. Actually, okay. I guess these are. Oh, it's the belts. I was gonna say like, oh, has it already disabled the motors? But like, I can press these around by quite a bit, but it's, well, first of all, it's the feet wobbling, but I can also see that they're slightly moving, but it's the belts flexing. Interesting, as I push down on these. Yeah, but z-axis, that's like, that is crawl speed. This thing can go so much faster. So to fix the direction, basically just swap all of these. This is all the direction settings for the z-axis. There we go. Save, update, and now that should be correct. Dancing switchwire code. Fan? Okay. Christoph, yeah. I do wish this room was a bit warmer too. So currently there is 1200 watts of infrared heating or halogen heating going on just to keep me warm, because this room otherwise would be like 16 degrees or something, and that is uncomfortable. You know, it's sunny outside. It's like 23 degrees. It's nice, but like I'm wearing jeans and socks and Birkenstock just to keep me somewhat warm. And in the, you know, in a shirt like this, it's almost a bit too cold. So no need to envy me for a cool basement room. M584 at the top. So yep. John Clark, you're living in the desert if it's 48 degrees for you. Like, why would you want to live in the desert? Why would you want to live where the air hurts your face? I mean, yeah, the Birkenstock are not helping me keep warm, but they are nice and breathable, and I prefer non-smelly feet over feet that are a bit warmer than they are otherwise. So let's just try that movement again. Z minus 5. Yeah. Can I actually set a movement speed here? Oh, feet rate, but that's extrusion? No. But yeah, z-axis is working. Yeah, if I do one more, then the y-axis direction is going to start crashing into the top gantry over here. So one more. How much space do we actually have? So I can give that a quick measure, because the Mosquito Magnum Plus obviously is longer than, you know, a Dragon Hot End or Standard Mosquito or V6. And nominally this is 300 millimeter size. And right now we are at the big reveal. It's 259, 260. Pretty much 260. So 260 millimeters left on this. Move the gantry back. Make sure the XY drag chain mount doesn't hit the Z idler during a home at that height. Okay. So the XY drag chain mount. Dark mode is kicking in when the features, yeah. Well, I mean, it is colliding. Drag chain mount is colliding at the it is colliding with the Z-axis tensioner, so I guess 5 less. Yeah, now we get the click out of the end stop. Okay, talking of end stops. Oh yeah, dark mode. Where is dark mode? Do we get dark mode? Dark mode? Dark mode? Is that better? I know it is. There's a webcam URL, by the way, as well. I know dark mode can be hard to read for some people with eyesight issues that are not just, hey, I've got -3 glasses or something. So that looks nice, but I believe this is actually more accessible for most people. So yeah. I'm gonna leave it bright for now. I know it's gonna bother some of you, but yeah, for accessibility reasons, I'm gonna leave it in light mode. What languages do we get? Oh, bunch. So next up, end stops. Do we actually get end stop status somewhere visually here? I think we do. Get. At least I remember seeing end stop status somewhere on the web interface. And not something I can click. I thought okay. Maybe not. In machine? In where machine? I might be blind. On the machine, you have to enable object model plugin. Yeah, Dexavis. That's exactly what I'm talking about. Why I'm leaving this in light mode. Machine specific. Left. Machine settings. I'm blind. Channel has a plugin tab. Plugins on the machine specific. No plugins, and then what do they enable? Object model. Object model browser. Okay. Okay, no idea. No longer in settings. Like I said, I firmly remember there being an end stop status view somewhere, but I can't seem to find it. Must have been changed around, moved around, something. So let's do this the classic way then. On the console. M115 gives us the end stop status. No, that's wrong. M119 gives us the end stop status. So X is triggered, Y is triggered, and Z is not sure. Okay. Z probe not stopped. So let's try the X and stop and see. Let's try and press that and see if anything changes. So okay, X and Y are backwards and they need to be inverted. So if I press the Y and stop, we should see X not stopped. Yep. So X and Y are flipped. And if I press both, both should be not stopped. X and Y are flipped and also need to be inverted. So show end stop status, yeah, M119 also works on Marlin. These G codes are pretty universal. There are some specific ones like all the 800 or 600 stuff for RepRap firmware, but most of the basic G codes work for both Marlin and RepRap firmware. Where's our end stops? Active high end stop for high end. Oh god, that's the pull up, and I believe that is the inversion. I could just change it in the settings tool and grab those files, and I think that is the easier way to do that. So we are IO mapping. We've got IO1, IO2 in active low pull up everything. First we need to unassign you. So you're at 2 active low and you're 1 active low pull up. That should be the correct config. And if we jump over here, we say finish and we open up the config G. We have our, where are they? End stops. That should be our new end stop config lines. S1P, there's the inversion with the exclamation mark, and they're backwards. So, nope. There we go. That should have both inverted the active low, active high for the end stops and swapped X and Y at the same time. So let's check that again. New config requires restart. Yes, Jason. It does require a restart, and it offers to restart that automatically. It offers to restart the board for you automatically. So let's jump back into the console. M11. I only have the commands in here. M119. X not stopped, Y not stopped, Z not stopped. So let me press the X end stop over here. And then X at maximum stop. And that's good to read that it's maximum stop because we are homing to the maximum position. And let's do the same for the Y end stop over here. Let's press that. And that is X is not stopped and Y is at maximum stop. Good. Good. You can also reconfigure live by just putting the commands into the console. Yes, you can do that. But then you would need to grab the same commands. You can plop in the same stuff that I've got in the... You could plop in that, basically. Maybe not all in one line. You could plop that in like that, but then you'd still need to save that to config.g or to config override. So that's X and Y. Next up, the probe, which should be configured as the end stop. So it has an LED on it that goes dimmer, which I don't like. I would like the LED to actually go off. So without it triggered, it is not stopped, and with it, it is... Oh, G-code. Come on. Whew! Yes. Z-probe works as intended. That's nice. And as I remove the... What? Oh, there's the Z-probe, by the way. There's a live readout for that. So as I move the crimping tool onto it, it live updates. So that's good. So while we have that, let me just use the steel rule to kind of check the trigger distance, and that looks about right. That looks like it's a millimeter off from the nozzle. So that should be good. it's impossible for me to show you that LED in there, but it triggers about a millimeter away from the nozzle. So when we home the Z-axis, it should not crash into the bed. It should actually stop. Okay. Time to run a home. Which is always scary, because if the home switch doesn't work, it might actually get some stuff out of alignment, but, well, only one way to find out. So we're doing G. Do we have home XY? We do have separate ones. Okay. So I'm putting my toe on the power switch, though I guess there is an emergency stop up here as well. Let's start with X. Home X. Home X. Moves up, slowly creeps over, and wow, that Z-axis. That Z-axis though. So let me move this over to like 150, and then home Y. So Y should move to the back and trigger. That Z-axis is crazy. First, the steel sheet is on. That is a PEI coated one. So I'm going to manually move this to the center of the bed. And then I'm going to just home Z. And I hope the home Z macro doesn't have any sort of XY positioning in it. So G28Z, if that is all that is, then it should be fine. If not, well, we might bend some stuff. Nope, that is accidentally fine? Yeah, front right is okay. Z home speed is also a bit slow, but yeah. So that is, I guess, homing speeds for a lead screw driven system, but I guess, well, we could speed this up just a bit because it's really slow. It's really slow. Trigger with a ruler just to be safe? Yeah, let me just trigger this. Damn. That's fast. My Z-axis is dropping. Nope. That is all intentional. You had home X and Y selected too? Nope. I only pressed home Z right here. If you do home all, then it homes X and Y, and if you notice, this is the front left. This is the, I guess this is actually 40-40 inwards from the edges, which might coincide, you know what I'm trying to say, coincidentally, also be used for the Z home spot, because this is our first spot for homing or for doing mesh bed leveling. If we had home X and Y enabled, it would be homing to the back right. That's the maximum for X and Y. So yeah, you put your hand under it. Nope. Nope. That's a bad idea. Yeah, so that's working. We have X, Y, and Z. Let's try and do a few faster moves, eh? How do we speed up the movement speed here in the interface? We can do a couple manual moves, right? So if we do G1, X, I don't know, 200? German keyboard. 200, feed. So feed is in millimeters per minute, I believe. So 6,000 should be 100 millimeters a second. Actually, let's just try this and see how that looks. Yep, that is a regular, normal, smooth move. So if we add a, maybe not a 0, but make that 500. Yeah. So that was 30,000 millimeters per minute. which is 500 millimeters per second. Let's go 2000. Let's go 2000. So that's 1,000 millimeters per second. Oh, and I actually need to move somewhere. Yeah, that works. So currently it is limited to 1,000 millimeters per second. What if you do a compound move? You move to x20, y250. So that should x20, y250 full blast. That should move it to the rear back corner of the bed in less than a second. 3, 2, 1, go. That was less than a second. Fantastic. And it's not breaking a sweat at all. Like, this is very comfortable doing it. Thanks for the five francs, Matthias. Thank you for the tip. I guess that is, yeah. You know, guys, you know, I'm always having a bit of a hard time being enthusiastic about stuff when I'm not actually enjoying what I'm doing. That I try to get to that American level of everything's perfect, everything is fine for recorded videos, because I can force myself there. I can convey a good mood in those situations. But when it's, you know, when it's live and when I've already streamed for 1.5 hours, that is hard. But that is having a printer work so smoothly without, like, there's been no fussing around. This has been perfectly smooth so far. There's not been any, oh, this driver doesn't work, or oh, we've missed a broken wire. We did find a broken wire last time, but there's no, there wasn't anything that was going wrong. That is just very pleasant to have every now and then. So yeah, that smile is genuine. We have the XY axis working at, honestly, like, mediocre speeds. I think this thing could easily go twice as fast with those motors, with the drivers, with the setup that it has. Could probably go a lot faster still. Let's try the Z-axis, shall we? What did we set up for the Z-axis? Z-axis was motors, 300 millimeters. That almost sounds boring now. 300 millimeters per second on the Z-axis, but still, we should get, you know, the entire Z-axis in a very fast time, or a very very low time. So Z 200 full blast. So that's 1,000 millimeters a second, but it's going to be limited by the limit we have set in Firmware. We could actually just quickly override that, but yeah. Z switch. Did I get it mounted? There is no Z switch on this printer currently. It is only the probe, but I might switch that around, get the probe out of here, and it's probably gonna melt. Get the probe out of here and install the Z tool length sensor at some point, but not right now. You guys ready? Does the question when we accelerate the Z-axis too fast and we slow it down too fast, does the printer jump from the inertia?
Hi all, everything is super awesome. Have a nice day.
All right, Z-axis. I don't know if I'm ready for this. Yeah, I wasn't ready for that. Let's do it again. That is what you get with a Voron. 240. These belts need some more tensioning. These are loose. Why are you so loose? I'm hoping that's not slipping. Oh, that shouldn't be. Can't be. That one is very loose. Worse than a 1990 washing machine. I guess if you have Z-hop enabled, yeah, that could be pretty bad. Where is our maximum speed settings? Let me see. Maximum speeds, just for fun. Let's just bump these up a bit. M203. So, what was that? So let's just uncork this and set this to 2000 millimeters a second. And I guess the same on the z-axis, because why not? Because why not? And that is the speed, right? Maximum speeds. Accelerations we can start tuning in then, but right now I'm happy with the accelerations. So that should not give or not have any sort of a limit on speed at this point. Z-axis might be a bit too fast, but change to Z. Hold on. What did I just send? Oh, I sent all Y. Okay, that's wrong. X, Z. Now we have it all unlimited for X, Y, and Z. So if we move, how fast are we going? We're going 300, so 300 by 60 is 2,100? 21? No. 21,000. So if you go G1, XX, yeah, we've already set Y. It's fine. It was wrong, but it's fine. If you go G1, Z, 50, and then go, so 21,000 was the 300 millimeters per second we were doing before. So if we go to 30, that should be 500 millimeters a second. A bit faster than before, right? Unless my math is wrong. And then we're gonna get some skipped steps, which might sound horrible and bend some stuff, but let's just try it. That was too fast. Okay, so Z-axis, we're good. We found the limit. That sounded horrible. I think it was also this belt skipping. It is not racked. It's not racked, so that's good. This one's a bit higher up, but okay, so we have found the limit for the Z-axis. When we restart this firmware, then it's going to default back to the settings.
Steps are so much more exciting than the football match. Keep the genuine smile and my Google rewards money.
So Z-axis, I think we're good. I just want to see X and Y. So where were we at? That was what we were doing before with 60,000, which is 1,000. So let's do 1,500. That is 1,500 millimeters per second. 1.5 meters per second. Oh, we're already in that position. Okay. Hold on. What? Don't think I've ever seen a printer go that fast. A printer this size go that fast. Okay, let's go full Jimmy. 2,000 millimeters per second. 2 meters. So I think we've reached the limit of how fast it can accelerate. I think that's really what's limiting us now. If you go back, yeah, I think that is all acceleration at this point. What about a diagonal move from the rear left to, let's see, X there, Y there, from the rear left to the front right. I'm gonna get my hand out of here. So that is mostly one motor doing all the work now. Yep, that's the limit. So 2,000 millimeters a second if it's uncorked, and if it's a comp. I don't know how the limiting actually works into it in RepRap firmware. Whether it's 2,000 millimeters a second on one motor, because diagonal moves are just one motor doing all the turning and the other one's basically standing still. Whether it's that for the diagonal move or whether it's X and Y compounded, which would be the 2800 millimeters effective per second on the nozzle. So don't know how that logic works, but it looks like 1000 millimeters a second. Very comfortable at the accelerations that we have. Current right now, oh yeah, these motors are super cold. But of course it is being, I'm only at 800 millivolts. What am I at? 800 millivolts. Well, we are at 1500 milliamps on the X and Y motors and 1200 on the Z motors. But yeah, that's. I'm gonna say that's good for now. That is definitely very respectable, and I mean in real life printing, if you're at 1000 millimeters a second, like forget about it. Okay. What I will try to do is move these up. Actually, I don't have to move these up. I just have to turn these off. Turn these off. E-stop. Good enough. So these should be powered off, right? Yeah. So before we start any crazy stuff on here, I'm gonna tension up these Y-axis belts because these are a bit loose. These in the corners here, front left and rear right are fine, I think, but this one is very loose and this one could use just a bit of tensioning as well. Then I shall get the Z-axes leveled off slightly, manually, not with any sort of fancy software assist. There we go. And I guess that's, well, I guess we need to turn, we need to tune the heater PID, at least we should. Though I'm just going to give it a go and heat it up and see how well that fares. Whether we actually need to tune the PID for the heater. That should be okay. G32, that's PID tuning. Okay. These should all be tight. Let me just verify what random internet citizen is telling me. G, that's M codes. Oh. Run bit.g macro? That's probing, but we've not configured anything for mesh bed leveling, really. I mean, we could do it once I've got these roughly leveled. But yeah, I don't think we have to. This should all be rather just roughly aligning these by eye. Because if you just use the center of the bed, that should be good enough for the most part. Why do you want to drop down? Oh, weird. Okay. G32 is what you need. Well, yeah, but haven't configured that yet. This macro normally uses the G30 command to probe the bed and then perform auto calibration of a delta printer. Or perform bed leveling by moving the Z lead screws independently. But have we set that up? Have we set? Does that just work? Does that literally just work? I mean, nah, we've not set that up. We've not assigned the motors to each corner, so that is not gonna work. I can see you guys trying to trick me. Haha. Have I validated Z steps per millimeter? I should do that, and that is a great idea that we can do right now. So X and Y I have validated with the ruler. And if you do the same thing for the Z-axis, so we're at 31 right now. I'm just aligning this to the, actually, yeah, that is a rigid part, yep. To the top of this black part. So if you move down by... we're not home because I reset this. Okay, makes sense. Let me set this to a reasonable position again and then manually move it down by 25 twice. Yep, that is correct. That is correct. Just realized I missed a tip a couple minutes ago from Matthias, and it is just starting to slide into the section where my screen for that is broken. Still, I did order a new one though, so should be fixed the next time if it gets here in time. 10 Swiss francs. Matthias saying, "Hey, your steps are so much better. We're so much more exciting than the football match. Is there a soccer football match going on?" No idea. But yeah, thank you for the tip, Matthias, and Oliver just saying guten Abend. Guten Abend to you as well, Oliver. So, steps per millimeter XYZ are correct. We do need to... I will figure out that, yes, Jim, I will figure out the independent corner leveling, I think, off stream. Bit too far outside my comfort region right now. Now I was going to read that off.
Need to get your 4 points assigned and G32 after belts are all same division.
Yes. Here's the 283 config to compare. Okay, that's going to be... I shall take note of that, Nero, thank you. But not going to do that current or at this point. What? That's a month old. Why did I not know about that? Okay. LG promised to stop trying to bribe reviewers now for screens. But okay, XYZ is set up. Z-axis is roughly okay. We do need to figure out the heater, if that is roughly okay as far as PID tuning goes, as well as bed, thermistor, bang, just, well, if it's bang, it should be okay. I think the Magnum Plus should be alright with pretty much any PID tune. It might be a bit slow. The PID loops that are working for like a V6 might be a bit slow because this is just a much larger thermal mass, but it shouldn't give any issues as far as overswing goes. So that should be alright. The bed should also be okay, so let's just get this heater heated up. And while that's heating up, I'm going to grab my FLIR camera real quick. Let's try 160 just to be safe. I'm going to get my FLIR and try and verify that, though. This is pretty reflective, so I probably won't get much out of that. But I mean, what we can I'm just realizing I forgot to install the PTFE in the extruder. I forgot to do that when I installed the hot end on stream. So that's heating up. What is that noise? That noise is the hot end cooling fan in front of the hot end. Trying to cool down the heatsink is this one. But I wonder why it's not going at full speed. It should just be running at full speed. Heaters, fans. Theoretically, if I'm reading this correctly, so it's running at 500 hertz, yeah, so that's obviously audible. Set value, H1, so it's monitoring H1 and it turns on at T45, but it should go to full speed from what I'm reading here. We left it at 0% in the config, right? I believe so. Yeah. But that is like when turned on. I believe that is when the printer is turned on, right? $500 is too fast. I was going to go for 20K. Anyway, while this is blocking our view, we are at 160 and we do get a nice temperature graph, which is very convenient. So a bit of overswing, but not too badly. I'm gonna say this is fine. I'm gonna say this is absolutely fine for at least pushing some filament through it initially. That is the minimal speed. Do we actually get? Well, let me see again. What do we get for config options here? There's the fan linkage. But I don't know how else this would. Okay. So let's try and fix this, because this should not have any noise to it when it's running. So if we just change this to 100%, hit finish again. Check out the config.g and check out what's changed there. Where's our fans? There's our fans. That's pretty much the same thing that we have in the config currently. So heaters, fans. M950, F0C out that. The only thing that has changed is this one is set to S1 and this one is at S0. So let's try that. Do S1 and see if that changes anything. Haha! It's interesting that that was a 0% fan, but it was still like, how did that spin at 0? How did it make so much noise and spin at that? Oh, that's like a lot. That's a lot of airflow. Probably more than the hot end needs. Just checking everything for temperature, and the probe is heating up. Yeah, you can feel the heat kind of radiating off that heater block, but yeah. Was it just the carrier frequency? Yes, Honza, that was literally just the PWM base frequency of the dimming for the fan. So yeah, this is full speed, and this is the actual fan noise. So what you hear is the fan actually acting as a speaker at that PWM frequency. Actually, you know what? I want to try the pipe cooling fan and see if that works. Oh, there's a turn everything off button. Machine movement, tool fan. Tool fan is at 100%. Oh, I can. Yeah, so if you're at 0, it's still on at 0. So that was literally trying to spin it at 0%, but that is not 0%. That is a lot more than 0%. How many wires does the fan have? One, well, two. Just DC non. I guess the computer world would call this a non-PWM fan, though we are controlling it through PWM. I mean, I think this is still fine. Yeah, I know that wasn't the part fan. This is still fine for the hot end, I think. At 100%, there is a lot of airflow. So if we switch over to fan 1, which is the... Oh, you're spinning as well. Hold on. Oh, that one we can turn off. Interesting. So tool fan, I guess because it's set as thermostatic control for the hot end, we can't really fully turn this off. It is always forced on to, I would guess, like 30% or something. So that's 100% on the hot end cooling fan because that is still at temperature. So now if you go to fan 1, hard cooling fan, just want to see like what the airflow is like down here. Oh, that is some good airflow. Yeah, you can still feel it down here. So, well, that's pretty good. That is pretty good. Unfortunately, it does not cool the probe, so that probe might be a melty one sometime in the future. All right, fans are working, and they're pretty noisy. Like, if I point the microphone at the printer, yeah, let's poke it in frame here. So if I'm right next to the printer, talking at a regular volume, then yeah, you can roughly hear how loud that is in relationship to my voice. With both fans running at full clip and with just the hot end, hold on, with just the hot end fan running. So yeah, it's not particularly quiet, but it's not particularly high quality fans that were included in the kit. Though, like I said, again, you could definitely turn down the RPMs on those fans because this is more than enough cooling for this setup. So let me just readjust this. Okay. Are you sure that thing will work? Of course. Theoretically, if I do home all, it should home X and Y and then move the tool head forward to this corner. And then do a Z home there with the probe. Oh, that wire got caught on the Z-axis drag chain. Okay, so that still needs to move out of the way. Yeah, slowest Z home ever. Volume is changing between the camera and PC capture feed. Why though? Why though? It shouldn't. It shouldn't. It seems like it's a bit quieter on the PC capture, but I don't know why. From what I'm seeing, it's the exact same volume. It's louder on the PC capture? Interesting. OBS is doing some weird stuff. How much louder though? Is it is it like an actual issue, or is it just weirding you out? If we go back here, audible. Okay, I'm gonna have to look into that. There's a saying, get the home speeds up. Where are those? The trigger value. I cannot find it. Ah, nice and quiet now. Home Z, okay. That makes sense. Home Z. Oh, there we go. Go to first probe point. So yeah, that is actually okay. That is actually the values that that I entered in the where is it? Mesh homing or mesh bed compensation. So 40 and 40, and then we have the 25 millimeters of probe offset. So that is literally this value that we're getting for this doesn't have a feed rate either. It's literally this value that the position of the first homing position is. Where's the F100? Yeah, but it's uncommented. So it's G30, and G30 is that beta-G. Probe the bed and enable compensation. Home Z by probing the bed. Well, okay. Unless I can find it right now. Yeah, I don't see any feed rates in here. I'm gonna have to figure that out, what that changes at some point. What else do we need to do for this printer to get it ready to accept a bed cheese configured right? Okay. What else do we need to get this thing running? Oh yeah, I guess we should test the bed and see if we can get that heating. So I don't know, 60. It is rising up pretty quickly. That is rising up very quickly. Fault. Rising much more slowly than the expected 1.7. What? Okay. Can I reset you? And is there a safety value for this? There is not. That's going to be something I will need to change in the firmware. Set you back to active. So Nero, bed currently is not running in. Yeah, bed is not currently running in PID. It's just running in bang bang. The thing with temperature reading on these beds is also because currently it is using that stuck on thermistor on the bottom of the bed. It's not going to be like the temperature readout right now of 30 something degrees. Okay, so it's faulting again. That temperature readout is completely wrong. So the top surface of this bed right now, this is maybe 30 degrees. This is not 40 degrees anywhere close. So yeah, again, I don't. With PID tuning, like, it can only do so much. The goal with PID tuning obviously is to reduce overshoot and to get the temperature like up there as quickly as possible without actually oscillating around your target temperature. With the thermistor just on the bottom and 8 millimeters of aluminum in between everything, like, I don't think there's that much point in PID tuning the bed. That aluminum slab is going to provide plenty of thermal mass and, you know, a way for the temperature to equalize and to slowly dissipate through it from the bottom until it reaches the top. And like, in the end, that thermistor reading on the bottom of the bed, like I said, is very, very far off. Tim doesn't, or thermal interface material, thermal paste doesn't really do much there, because it's like the thermistor is only coupled to the heater itself. It is not coupled into the aluminum. It is on the, so the stack up on this is, we have obviously the print surfaces up top, we have the aluminum bed, we have the heater, and then on the bottom of that heater is the thermistor. So the heater will want to dissipate its temperature in both directions. Half of it goes into, initially when everything is at the same temperature, half of it goes into the aluminum, the other half goes into the bottom. And once that bottom is also at temperature, like, that's going to start pushing more heat up. But that bottom side where the thermistor is attached, that is going to heat up much more quickly than that top side aluminum. So yeah, it's that thermistor has no chance of reading accurate temperatures, which is why in the past I have installed a thermistor into the actual aluminum bed to read the actual temperature of the aluminum. So once I do that on this printer, that will allow us, or that will give us a chance to make a to get PID tuned in, to get a reasonable response on that heater, and to actually have a value from that heater read back to us that makes sense. So yeah, that's that. So safety on the heater is still triggering. That I will need to figure out. But that movement is good, accelerations are good, speeds are good. To do for me for next time. And I think that's going to be off camera because it's screw-ups on my side that we'll need to fix. We need to do safety. So we need to do bed safety. We need to do PTFE on the extruder. I need to do extruder direction. Actually, we can try that right now. Extruder calibration. And then nozzle offset. And nozzle offset I will need to look up, because that is always something that I dread with RepRap firmware. It's just so illogical for me. Like, where do you save your nozzle offset? There is a baby stepping. I think that's in status here. Yeah, there is a baby stepping setting here, but I don't think that is being saved by default. So you would need to manually baby step the nozzle to the position. You can calibrate it once and then kind of set an offset. So yeah, fix G32. Yeah, G32. So yeah, you can set a nozzle offset once and then save that to the config, and that is getting stored. And then if you need it for that specific print, you can use the baby stepping to add on top of that. And yes, quad gantry. Gantry. So that's stuff that I will do off camera for the next stream. But I think right now we are pretty much done. I've promised to do firmware today. We have firmware today. We do have the first moves. And I will do these things until next time, and then report back once we've got everything ready for a slicer profile and for a first print. So next stream is literally just going to be first print, right? That's all that's left to do. Or once this is done, that's all that there should be left to do. And yeah, like I said, that's it for today. Thank you all for being here. Thank you all for being helpful. I know it's a short one today, only a bit over 2 hours. It's Sunday. All right. Enjoy your Sundays, everyone. Thanks for watching. Keep on making, and goodbye.